So we know that if we have a function, for example, we want to integrate x over x squared plus 1 dx, we can integrate it directly by using substitution, and we get the answer, which is here half ln x squared plus 1. And because it's indefinite integral, we have plus c. We also learned that we can also combine two fractions, have one function that can be subdivided into two or more fractions. For example, if we have the fraction 5x minus 10 over x squared minus 3x minus 4, this fraction is the same as the two fractions at the beginning, which are 2 over x minus 4 plus 3 over x plus 1. However, we have the left-hand side of the equation will be easier to integrate than the right-hand side of the equation. So we can integrate 2 over x minus 4 plus 3 over x plus 1, and we have 2 ln x minus 2 plus 3 ln x plus 1. So how do we find the two numerators so that we end up with these two fractions? We had done that, and remember, because we have two factors from x squared minus 3x minus 4. That is what directs us to how many fractions we can form from one function. And each factor makes a fraction. So 5x minus 10 over x squared minus 3x minus 4 can be rewritten as a over x plus 1 plus b over x minus 4. And you can see x plus 1 is one of the factors in the denominator, and x minus 4 is the other factor. Then we find a and b, the two unknowns. So we can rewrite this equation by getting the LCM of x plus 1 and x minus 3. Then what we get is equated to the numerator that we initially had, 5x minus 10, because the denominator is the same. And from there, we can work out what a and b are. You can expand, and then you equate the corresponding terms or the like terms, or you can make one of these factors 0, like this one. If you want to make this 0, then we assume x is equal to 4. Or we can make this 0 and assume x is equal to -1. Then we substitute and get the remaining unknown. So from there we have a is equal to 2 and b is equal to 3. And hence the two partial fractions are 2 over x plus 1 and 3 over x minus 4. And that is what we integrate, because integrating this will involve a lot. Now we know that for us to express a given fractional function into partial fractions, the degree of the numerator must be less than, it's strictly less than the degree of the denominator. However, if we have a case where the degree of the numerator is greater than that of the denominator, like the example we have here, you can see the degree of the numerator is 3, while if we expand this, we are going to get a degree of 2. Then in that case, we do division. We divide the numerator by the denominator. And like in this case, when we divide, we get x plus 3 plus 7x plus 6 over x plus 1 into x plus 2. So from here, this first part is easily integrable, while this we can now express as partial fractions using the same procedure that we have used up here. And that gives us 8 over x plus 1 minus 1 over x plus 2. Therefore, what we have now, we can easily integrate, because integrating x, 3, and 8 over x plus 2, and 1 over x plus 1, that we know, to give us x squared plus 3x plus 8 ln x plus 2 minus ln x plus 1. So we can also decide to express it in this form, because we know when we multiply a log by a number, that number can be made a power. That's why we have here power 8. And then we are dividing, because here we have minus. And when we subtract logs, it's the same as finding the log of the two numbers divided. So the denominators of the partial fractions must not contain factors from other denominators. Each partial fraction is different from the other. There's nothing the same in any of the partial fractions, the denominators, that is. So in case we have 1 over x plus 3 into x plus 1 into x minus 3, that in partial fractions, a over x plus 3 plus b over x plus 1 plus c over x minus 1. Of course, we work out the values of a, b, and c. But we don't write the partial fractions in the form given below. So we don't have a over x plus 3 into x plus 1, and then again b over x plus 3 into x plus 1. This should be different in each case. So you either take a over x plus 3, then plus b over x plus 1, or a over x plus 1, then plus b over x plus 3. So you can convert, for example, this given fraction into partial fractions, and then you integrate. We have many examples that we had done earlier, if you can remember. And now if you do this, you'll end up with b is equals to 1, a is equal to minus 1, and then you integrate to get ln. And when we use ln, you will find that in many places the answer is ln of the absolute value. These two lines mean the absolute value. And plus c, because of course in this case we have indefinite integration. So we can solve, for example, this, and you need to be very keen to find out what type of equation you have in the denominator. Is it an expression that can be factorized, or is it an expression that we cannot factorize? So if we have 1 over 9 minus x squared, this is one of the identities that we learned in high school, a squared minus b squared. And we can easily factorize this as 3 minus x into 3 plus x. Then from here, you find the partial fractions, and then you integrate. So you can see here a is equals to 1 over 6. That is a fraction. Of course, this is also a fraction, but what I wanted to inform you about is that the numerators can also be fractions, not only whole numbers. Of course, when it's a fraction, it means that it can be rewritten in decimal numbers if you so wish.